What if we could spot an earthquake before it strikes? What if there were clues that could alert us of an impending tremor? Is earthquake prediction possible or just a fantasy? Hello and welcome to Curiosity, where we explore fascinating and interesting topics about everything. Today, we are going to talk about earthquakes, those sudden and violent movements of the Earth's crust that can cause devastating damage and loss of life. Earthquakes are caused by the release of stress that builds up along the boundaries of tectonic plates, the large pieces of rock that make up the Earth's surface. When these plates move past each other, they sometimes get stuck, creating friction and pressure. Eventually, the plates overcome the resistance and slip, releasing energy in the form of seismic waves that travel through the Earth and cause shaking. The location where the slip begins is called the hypocenter or focus, and the point on the surface directly above it is called the epicenter. The magnitude of an earthquake is a measure of how much energy is released at the focus, and it is usually expressed on the Richter scale, which ranges from 1 to 10. The intensity of an earthquake is a measure of how strong the shaking is at a given location, and it is usually expressed on the modified Mercalli scale, which ranges from 1 to 12. But how can we tell if an earthquake is about to happen? Are there any signs that could warn us of a major quake? Well, there are some phenomena that have been observed before or during some earthquakes as follows, but they are not reliable or consistent enough to be used as predictors. Some animals may behave strangely before an earthquake, such as becoming restless, agitated, or fleeing. However, this behavior could also be caused by other factors, such as weather, noise, or hunger. And not all animals react the same way or at all to seismic activity. Some people may feel dizzy, nauseous, or have headaches before an earthquake, possibly due to changes in air pressure or electromagnetic fields. However, these symptoms could also be caused by many other reasons, such as illness, stress, or medication. And not everyone is sensitive to these changes or feels them at all. Some lights may appear in the sky before or during an earthquake, such as flashes, glows, or auroras. These are known as earthquake lights, and they are thought to be caused by electrical discharges from rocks under stress. However, these lights are rare, unpredictable, and not well understood. And they could also be confused with other natural or artificial sources of light. Some sounds may be heard before or during an earthquake, such as roars, rumbles, booms, or hisses. These are known as earthquake sounds, and they are thought to be caused by vibrations of rocks or air under stress. However, these sounds are also rare, variable, and not well understood. And they could also be mistaken for other natural or human-made noises. As you can see, none of these signs are conclusive or universal indicators of an earthquake. They may occur in some cases but not in others. They may occur in one place but not in another. They may occur before a large quake but also before a small one or none at all. They may have other explanations besides seismic activity. In short, they are not reliable enough to be used as predictors. So, is there any hope for earthquake prediction? Well, some scientists have recently found a subtle signal that occurs hours before a large quake that could potentially be used as a precursor. This signal is called an aseismic slip, and it is a slow and silent movement of the fault where the quake will originate. An aseismic slip is different from a regular seismic slip, which is a fast and violent movement of the fault that causes an earthquake. An aseismic slip does not produce any seismic waves or shaking because it happens too slowly and smoothly. However, it does cause a slight displacement of the ground that can be detected by GPS sensors. To find out if faults show any changes in slip behavior before earthquakes, the researchers analyzed data from thousands of GPS stations near the centers of 90 earthquakes around the world. They found that in most cases, there was an increase in a seismic slip rate about 2 hours before the main shock. This increase was very small, on the order of millimeters per hour, but it was consistent and significant enough to be distinguished from the background noise. The researchers believe that this increase in a seismic slip rate is a sign that the fault is becoming unstable and ready to rupture. They think that the aseismic slip is caused by the weakening of the friction between the plates due to fluid pressure, thermal effects, or chemical reactions. They also think that the aseismic slip triggers the seismic slip by reducing the stress on the fault and allowing it to break more easily. This finding is very exciting because it suggests that there is something happening before large earthquakes that could potentially be used as a precursor. However, it does not mean that we know how to predict them yet. There are still many challenges and limitations to overcome as follows before we can use this signal as a reliable and practical tool for earthquake forecasting. The increase in aseismic slip rate is very small and difficult to measure. It requires a dense network of GPS stations with high precision and accuracy, which is not available in many parts of the world, especially in developing countries where earthquakes pose a greater risk. The increase in aseismic slip rate is not specific to large earthquakes. It could also occur before small quakes or none at all. It could also vary depending on the type, location, and geometry of the fault. The increase in aseismic slip rate does not tell us exactly when, where, and how big an earthquake will be. It only gives us a rough estimate of the probability of an earthquake occurring within a certain time window and area. Therefore, more research is needed to understand the physics and mechanics of aseismic slip, to improve the techniques of GPS data analysis, and to test and validate the results with more data and cases. In the meantime, we should not rely on this signal alone to warn us of an earthquake. We should also follow the recommendations of experts and authorities on how to prepare for and respond to an earthquake as follows. Know the signs of an earthquake. During an earthquake, you may hear a roaring or rumbling sound that gradually gets louder. You may also feel a rolling sensation that starts out gently and, within a second or two, grows violent. Know what to do during an earthquake. If you are indoors, drop to the ground, take cover under a sturdy table or desk, and hold on until the shaking stops. If you are outdoors, move away from buildings, trees, power lines, and anything else that could fall on you. If you are in a vehicle, pull over to a clear location and stay inside. Know what to do after an earthquake. Check yourself and others for injuries and provide first aid if needed. Check your surroundings for damage and hazards such as fires, gas leaks, or electrical wires. Follow the instructions of emergency responders and evacuate if necessary. Be prepared for aftershocks, which are smaller quakes that follow the main one. Earthquakes are one of the most unpredictable and destructive natural disasters that can affect our lives. But they are also one of the most fascinating and intriguing phenomena that can teach us about our planet. By studying them, we can learn more about how the Earth works, how it changes over time, and how we can adapt to its challenges. We can also discover new ways of detecting them before they strike, which could save lives and reduce damage. That's all for today's episode. Thank you for watching Curiosity. If you enjoyed this video, please like and subscribe for more content like this. And don't forget to share your thoughts and questions in the comments below. Until next time, stay curious.